Yep, so we can start. So welcome on DataOps Poland Meetup. Today we have the special guest, William from China. So it will be story about DataOps and the data and all the operations on the data. So William, welcome on our meetup. Stage is yours. I'm presenting. So
okay.
Now you take the screen.
Okay, I share my screen.
One more thing before we start. So you would like to typical Q&A session at the end, or we can stop somewhere in the middle, read the question from the chat, or whatever. Up to you.
I will leave the time for at the end where you can have a conversation about the question or something issue you can ask at the end of my presentation.
Okay, let's do that.
Yeah. Okay. So I will begin my presentation. And hello everyone in Poland, and it's very nice to meet you here. Today I will share some experience on modern EtLT and orchestration architecture in DataOps. First, let me introduce myself. My name is William, and I'm Apache Software Foundation member, and also Apache IPMC member, and also the PMC of Apache DolphinScheduler, the mentor of Apache SeaTunnel. And also, I run an open source community called ClickHouse China. So many ClickHouse users are in China are in my group. And also, I'm the director of workflow and data governance of Apache Kong issue in the last year and the year before last year. I used to work at IBM, Teradata, CICC, Lenovo analysis, and I work in big data area almost 20 years. So today I want to share something with you. The first topic is about the new architecture of EtLT. And then I will share some experience on new EtLT tools called Apache SeaTunnel. Then I can share some experience on new orchestration tools. We call it Apache DolphinScheduler. And also I can share some new concept in DataOps and something happened in China and something I know happened in America. So then we can have a discussion on what happened in DataOps. Okay, so this is the agenda. And first, I like to introduce you the new architecture of EtLT. Actually, both in China and American, we found that there is a fact that more and more people are using data, not like the old days. In old days, just engineer or data scientist or just the data architect are using data platform. But in nowadays, not only the engineers, but also, for example, the sales analyst or the procurement office or the HR manager or other people, the business people will use the big data platform directly, not just look at the report. So in this background, I found that separated the data scheduling integration, they are separated with your data warehouse, data lake, and big data. Many enterprises have one data warehouse and have the other data lake. They're different systems. And also there will be many data processing. For example, CDC means change data capture and the batch data stream. And you just use CDC batch and a data stream between different traditional data sources like Oracle, MySQL, SQL Server, but also some emerging data sources like AWS Redshift or S3 or some Snowflake or something like that. So there's too many data process between different data sources. And I also found that not like DevOps, actually development in data or in big data, the development process is managed separately in different development systems. And the code is scattered everywhere. and managed by different teams and different rules, because the users are not only from the engineer, but also some business people or business department people. They are using the big data platform, so it's very hard to control them. I think that's one factor that why DataOps is popular in Poland and also in China and in America. And we found that the new data sources and new data processing are existed everywhere. So now we have a new kind of spider web of data, because there are too many data sources and too many data processing. So in that background, I found that the data architecture, data processing architecture is changed. In old days, we all know ETL, extract, transform, and load. In old days, like Teradata and Greenplum or Oracle DB2 time, we use data warehouse, and also there's ETL tools like Informatica or Talent or Cattle, something like that, to process our data. And then big data come. We are using Hadoop, and we are using Hoodie, and we are using Spark. Then the architecture is changed from ETL to ELT. ELT means to extract the data from your data source and load data to your Hadoop. Then we are doing transformation in your Hadoop or in your big data platform. And nowadays we found more and more data come into our enterprise, such like cloud data, SaaS, and hybrid cloud data sources. So now I think the whole architecture is changed from ETL to ELT, then to ETLT. There's a small, I think it's a lowercase t transform. So ETL, E also means extract, and then lowercase transform, then load. Lowercase transform, that means it's not like the transform in your data warehouse. It will not, there will be no business rules in your small lowercase transform. In your lowercase t load ETL this processing, you just extract data from your all kinds of your data source. Perhaps it's a Kafka, or you extract data from your database or from your cloud by using JDBC or CDC or file or software API or cloud API or SaaS API. And then you can do some data type transformation, or do some filter, or do some UDF on your column, or you clean your data, and then you load your data into your data warehouse or big data or data lake by using JDBC, bulk load, or API load, or reverse ETL, something like that. And then the business people can write SQL or can write their business rules in your data warehouse. So you can see that ETL is done by your engineers. That's data engineering. This kind of tools is always used by ETL developer, DataOps engineer, or data security engineer, or architect. When the data is loaded into your data warehouse or data lake, like Hoodie, Hive, Trino, or Hawk, or ClickHouse, your business people or your data application developer will use the data directly, and they will write SQL, and they will do CI/CD and do ad hoc query on your data warehouse. And also data scientists and AI engineer will use data in your data warehouse. So the whole process will be extract, CDC, normalization, and load to your data warehouse. Then you can use IDE, and you can write SQL in your data warehouse. Then you can do some AI algorithm in your AI platform. And for the workflow, no matter for the real-time workflow or the batch job workflow, there will be orchestration tools along with the whole process. So this is the EtLT architecture. And I just gathered some open source modern data stack tools. And for data integration, we can find that, for example, Airbyte in American, or SeaTunnel in Apache Foundation, or Jitsu, or DataX in China, or RudderStack in Europe. And also in data warehouse, there will be not only for Hadoop, but also for OLAP engines such as TrinoDB, ClickHouse, Peanut, Iceberg, Materialize, Doris, and many other OLAP engines. And for transformation part, Flink is very popular in China, and I think DBT is very popular in American, and BIM is popular in North America, and also Spark is powerful all over the world. And also there's a Smansa for transformation. And for orchestration, many people use Apache Airflow outside China, but the most popular tools in China is DolphinScheduler. And also some people use Flight for AI training. And in American, some people are using Dexter or Perfect for the workflow orchestration. And for data analysis, there will be Superset. And for another tools called eChart is something. It's a UI tools. You can draw very very beautiful chart with eChart. And EtLT, that's open source project by Alibaba, and I know many people are using Currybook in American, and the Redash, Metabase, and the Ladash. There's some analytics tools, and there's many AI open source projects like PyTorch and Ray. I know ChatGPT is very popular in the last few days, and I think they are using Ray behind the AI model. And Baidu just open source Paddle, and also some other AI open source project like Jupyter, TensorFlow, OpenMLDB, MindSpore. So there's many new open source modern data stack tools. If you want to investigate, you can just Google them, and you can find that they are very popular, both in China and in all over the world. And here is an example that if there's a big data architecture, when people use EtLT and orchestration for DataOps, I think it's mostly in China, but also some people are using in American. They're very similar. When we mentioned about DataOps, that will be two kinds of data ways to use data. One way is we are using real-time data. That means we just collect data from your IoT devices, or from your database, or from a log, or from a SaaS. And then actually we can use a SeaTunnel agent or SeaTunnel CDC connector, that means change data capture connector, or just a JDBC connector to read your data in real time. And CDC connector can read the data not by JDBC, but by read the bin log, and just explain the bin log to the SeaTunnel data map. And we can use SeaTunnel data engine to synchronize the data to Kafka, or just do some real-time load to your real-time data warehouse, like ClickHouse or Peanut, to do some real-time OLAP. And then you can using Superset or Redash to see the real-time dashboard. And also you can use a SeaTunnel to synchronize data to your SaaS API or to your software API. Then you can get a real-time alert. And also, because SeaTunnel can read data once, at the same time, it can write different data source many times. You can synchronize data to your real-time data engine, and also you can synchronize, at the same time, you can synchronize data to your data lake and to your data warehouse. So this is the real-time data processing. And for the batch data processing, we can just read data from flat file, from a message queue, or from a database, or cloud database, or NoSQL database, something like that. We can just write a SQL-like language to do the to read the data and transform the data, and do and then you can just do some normalization and do filter. Then you can load data to your data lake, like a Hoodie or Hive. And if you are using Hoodie, I think SeaTunnel now we are going to support schema evolution. That means if you are using MySQL, you add a column, then your Hoodie will also add a column, and you needn't to change the code of your ETL program. You just it will automatically change the target database along with your source database. And also SeaTunnel support multi-thread read and multi-thread load. And there's another connector we call a bulk load connector. That, for example, we can bulk load data into ClickHouse, not by JDBC, but by write the ClickHouse data file and then connect the data file to the ClickHouse. So that will be much faster than you're just using JDBC to insert to ClickHouse and other OLAP engine. And this the SeaTunnel batch this is how SeaTunnel to process batch data. And for DolphinScheduler is just a tool that like a traffic light in all jobs. No, not only batch job, but also for real-time job. For example, it control the CDC and control the Flink or Spark streaming job, and it has IDE and CI/CD tools, and also it has some workflow operations. And also DolphinScheduler now support AI tools such as TensorFlow, SageMaker, or PyTorch. You can use just like you do something data preparation, and then you can do the training, and then you can just put your model online. This is a workflow, and you can control the workflow by DolphinScheduler, not only to prepare data or just to the CDC jobs. And also SeaTunnel has some connectors from your data lake or data warehouse to your SaaS or to your software. So someone call it reverse ETL, such as it can you can connect you can just extract data from your Hoodie, then load data to your Oracle or to your Azure or to your some SaaS or to your Luck or something like that. And this is the architecture of big data platform. I think it's very popular, at least in China. And so the second part, I will introduce you the ETL tools called Apache SeaTunnel. And actually, Apache SeaTunnel, we call it next generation data integration lowercase t l tools. That means it has Apache SeaTunnel has more than 100 connectors that it can read the data, can extract data from different data sources like Postgres, Kafka, Elasticsearch, and or Kudu, HBase, Woody, something like that. And then it can transfer data and synchronize data to your data target. Perhaps it's MySQL, perhaps it's Woody or Hive, or other, or Kafka, or other kind of database. And now it has its own computing engine. We call it SeaTunnel Zeta Engine. It's not like other synchronization tools. They are based on Flink or Spark. Because SeaTunnel has its own Zeta Engine, it's only designed for synchronization. So if you are synchronizing data from different data source, you can just deploy SeaTunnel without Flink or Spark on your cluster. So you can see there are more than 100 connectors that help you to synchronize data to almost anywhere. We have a cloud connector like Amazon DemoDB or from your Data Hub. And also we have some database connector like Cassandra, DB2, Doris, or Elasticsearch, and many Greenplum, InfluxDB, IoTDB, and could do something like that. And also we support SaaS connector like DingTalk, WeChat, Slack, I think Slack, and other like Notion or OneSignal. There's many SaaS connectors. And also we support a message queue and support a system like local file, FTP, and OSS or S3 or something like that. You can see that if you are if you want to synchronize data from different data sources, you can use SeaTunnel to synchronize data from almost any data source you want. And I think there are some good features that why just we create Apache SeaTunnel. First, we build Apache SeaTunnel in an easy way. It's very easy to deploy and very easy to use. You needn't to deploy HDFS, Flink, Spark, or something like that. And because it's only designed for data synchronization and integration, so the performance is very good. You can just use one server, like 3 CPU core and 8 G RAM that can synchronize data several millions of records in several seconds. So it's very powerful in data synchronization and integration. And now it supports more than 100 data sources, and it's growing very fast. In the last year, in the beginnings of the last year, we have only almost 20 connectors, and in the end of the last year, we have more than 100 data sources. So the connector grow very fast, and the programming is very, very easy. We designed it just a SQLite code. I can show you how to use it. It's very easy, and also it can support not only batch mode but also support CDC mode. And your program needn't to change. They are using the same part of SQLite code. You can just extract data from your data source to your target database by batch mode or by CDC mode. And now it support, we call it multi-table synchronization. We have a scenario that there are many data tables in your source database, and you just want to synchronize all the data to your target, like synchronize data from MySQL to Hoodie or MySQL to Hive, and SeaTunnel support synchronize data multi-table in just one job. The performance is very good. And also, we are going to support schema evolution. That means you just alter table in the source database, and the target database will be altered. The table will be also changed. And now it's support dynamic extension. That means you can add servers in online, and you can add server, or when the job finish, you can release the server online. And now it supports CDC. That means it can extract the bin log and also store them in Kafka. And we are going to support data flow speed controlling. And because SeaTunnel is a distributed system, and we can support resume at break one. That means if there's some error in your data source or some error in your target database, you can resume at the breakpoint, and we can assure that the data will be read and write, exactly once. Read if something error happened, perhaps we will read the data several times, but we can assure that write is exactly once. And now it supports many cloud like AWS, Azure, and some database on cloud. And it is designed on, we call it multi-mastered and multi-worker. That means it's scalable and the stability is very good. And now many people are using SeaTunnel, I think in China and in Singapore. It can support hundreds of billions of records synchronization. So SeaTunnel architecture is very simple. We have a source connector, we have a transform, and we have a sync connector. Source connector just reads the data and translate it to SeaTunnel data format. And sync connector just write data to database or to S3 or Kafka in real time, load or bulk load. That's a sync connector. And the transform just do some data filter, or split one column to two column, or replace one column with other context, or we just if there's a null in your column, we can transfer into another typical word or typical character, and we support UDF or SQL. So here is a very easy example that we are using SeaTunnel just extract data from IoTDB to cancel. The whole program is just like this. You define the environment, and you define the data source, the name, password, and how to extract data. You just use SQL, and then you can. There's no transformer, and transformer is also is just like a SQL like a program, and you can design how many parallelism to the whole things, and some other field. And for sync, we just write a console here. So the result is like this. Just read the IoTDB and then to your console. So it's very easy to use for the programmers. You needn't to know the Scala or something like that. You only define which kind of a database you want, and which kind of database is your target. And your filter is just like a SQL-like filter. So it's easy to use. And now many people use SeaTunnel. One of them is we call it Bilibili. It's just YouTube. It's YouTube in China, and it's Bilibili are using SeaTunnel just to synchronize data more than 100 TB and per day. And also there's another company called VIP.com. It's just like Alibaba, Taobao, but it's smaller than Taobao, and it's using SeaTunnel to synchronize data from MySQL to Presto to Kafka to Spark and to ClearHouse and to Huidi, just synchronize different data sources, and both in real time and batch mode. And also there's many other users both in China and in Singapore. And SeaTunnel history is like this. This project is also open source in 2017, and it entered Apache Incubator in 2021. And we just released the SeaTunnel data engine in the last year. And now in the end of last year, we support almost 100 connectors. And if you are interested about SeaTunnel, because it's Apache open source project, so it's free to use, and we have an Apache website. If you're interested in SeaTunnel, you just visit seatunnel.apache.org, and you can visit the GitHub. I think the story is almost more than 4,000, and I think it's 700, more than 4,070 stars. You can visit our GitHub, and you can also join the Slack channel where you can watch the Twitter, where you can see the Medium, some article in Mediums. And here is the new EtLT tools. We call it Apache SeaTunnel. It's a very popular in China, in Singapore. And I also want to introduce you another new architecture tools we call Apache DolphinScheduler. It's a very interesting orchestration tools. It now is more than 10,000 stars in GitHub. And in old days, we just use the cron tab in Linux for the data orchestration for the jobs, and it's not very good. Then we have Azkaban and Airflow, but Azkaban Airflow is not designed for, it's not visualized design, and it's also cannot adopt Kubernetes very well, and DolphinScheduler is designed based on cloud-native idea, and it has multi-master and multi-worker. That means it's scalable, and stability is very good. And also it has its own, we call it DolphinScheduler operator on Kubernetes. So it's very easy to use to control your Spark on Kubernetes or Flink on Kubernetes, or it itself can deploy on Kubernetes. And also it's designed by visualization tools. You can just drag and drop to create your workflow. And then now it's it has more than 3,000 active users. Most of them are in China, but some of them are in American and in India and in Singapore. And I think some people are in Europe, but very small people. So if you are interested, you can investigate investigate that. And it has more than 400 contributors in open source community. And this is a DolphinScheduler architecture. It's not like Hadoop or Airflow. Hadoop or Airflow have a active master, and there will be another we call the standby master or standby node, and the worker server will be lots of worker server. So the DolphinScheduler has many master server, and each of them are active. So that means if you have many workflow or task, part of the workflow will be running on one of the servers. And if the one master server down, there will trigger the process we call the rebalance, and then the whole snapshot will be transferred into the other master servers, and then in that ways we can assure that no matter any of the server is not working, the whole cluster will be working. So we call it multi-master and multi-worker architecture design. And you just create a workflow by drag and drop or by passing. In Airflow, you can just use to passing to create a workflow, but it's very hard for some data analysts, just like I mentioned, many people are not engineer background. They don't know Python. They only know SQL. So how to let this kind of people to use big data platform or use a data warehouse? We just drag and drop to create the workflow, and you double click the task. You just write SQL in the task. Then you can save and run and schedule your job. So it's very easy for the person who are not engineer background. And now DolphinScheduler supports many kind of Spark tasks, such as Shell, SQL, Spark, Flink, MapReduce, Python, HTTP, and Scoop, and also SeaTunnel, and the data quality, and many other tasks like AI tasks. And we also have some we call logical tasks. For example, sub-process. That means you can use other workflow, just like in this workflow, just like a task. That means just like a call a procedure of another workflow. And also it support like I think condition that if then or switch. That means we have a global parameter that you can design the whole DAG in different situation. For example, if the result is 1, the workflow will run this way. If the result is 2, the workflow will run it in the other way. So this is the UI of DolphinScheduler, and it has many features. We design what you see, then what you get workflow, and it has high reliability, and also it has rich workflow functions. You can support or resume workflow. You can support projects and multi-tenant, and support many data type task type, and also support user-defined task, and you can support condition sub workflow. And in the newest version, we just support machine learning orchestration. You can just use it in your data preparation and machine learning ops. And it supports real-time support Flink and Spark streaming, and also support Python and YAML to generate your workflow, and also support Kubernetes support in the newest version. And someone just do a comparison between DolphinScheduler, Azkaban, and Airflow. I think it's many features. I think you can just you can see here. I think the key difference is like here. The creating workflow is quite different. Azkaban can only use XML, and Airflow use Python and OpenAPI, and DolphinScheduler can use UI and Python and YAML and API. And DolphinScheduler, there's a task called data quality control. That means if you are using DolphinScheduler, you can just you can decide the workflow will be to the next step by the data quality. If the data quality is no good, and the workflow can be failed, or can be wait for the data quality be okay, that will be then the workflow will be running. And also we call it single point of failure because DolphinScheduler is the decentralized design, so I think it's stronger than Azkaban Airflow. And I think also DolphinScheduler support multi-tenancy. If you are using Yarn or Kubernetes, that means it can you can design your tenant in your Yarn or in your Kubernetes. The DolphinScheduler can control the resource in Yarn and the resource on your Kubernetes. And I think the other things I think also it support a workflow version. That means if you save your workflow, DolphinScheduler will control the version control. And also it support backfill our dependencies and our real-time job. I think so there's some features there. Azkaban and Airflow are very good tools, and DolphinScheduler is more powerful in some area. And DolphinScheduler is trusted by many infrastructure leaders, both in China and outside China. And here are some typical use case. One is we call the high performance, high volume of task scheduling. For example, China Unicom, this is the secondary. This is the second largest telecom company in China, and it has more than 1 million tasks in their orchestration platform. So that they just compare Airflow, Azkaban, and commercial scheduler. China Unicom finally chose DolphinScheduler as their orchestration platform because they has so many tasks. So they are using about more than 70 servers of workflow orchestration clusters to control their Hadoop cluster. I think is more than 50,000 servers of a Hadoop cluster, and the whole ETL jobs, I think, is more than 1 million. Is more than 1 million jobs. So that's China Unicom, and also this is Alibaba Cloud, and also Ping An and Jianxin is some enterprise in China. And this is the one kind of a user who are using DolphinScheduler. The second kind of user is like a Shein and Shopee and McDonald's, and also I think Cisco. That web company are this kind of user. They are using Kubernetes on AWS or Kubernetes on Azure, and they run the whole big data on cloud. Shein has more than 40,000 jobs on AWS, and Airflow cannot support that big number of tasks. So they just migrate from Airflow to DolphinScheduler, and then then they are using the DolphinScheduler UI to meet the requirement for their data analyst. Then it's very easy to use for their end users. Then they just migrate from Airflow to DolphinScheduler. And also McDonald's in China is using DolphinScheduler. And also there are some other enterprise are using DolphinScheduler as their AI and machine learning orchestration platform. LegiFM, this is I think there is no compare app in the US or in other place. It's a podcast. Yeah, it's a podcast platform, and that is very popular in China. And also 360 is security. It's the biggest security network security company in China. They're using DolphinScheduler as AI or machine learning orchestration tools. So there's many other use cases. If you are interested about DolphinScheduler, and you can visit dolphinscheduler.apache.org, and also you can visit the GitHub because it's Apache Foundation projects, so it's free to use and free to deploy on your enterprise or on your customer's enterprise. And also we have a Slack channel and Twitter and Medium. This is what I introduced. It's about orchestration tools, ETL tools, and finally, I want to mention some DataOps and some new concept, especially in China, so we can discuss. Then we can have some discussion. Actually, the DataOps, there's many. I think not only China but also in Poland, there will be many ops. For example, DevOps, SecOps, GitOps, NetOps, ITOps. So just many ops. So actually, for data, I think the whole life cycle of data is generate data. Then the data will be stored into your OLTP system like Oracle or MySQL. Then you will do some ETL, or you want some report or dashboard that will integrate the data into your data lake. And if perhaps you have to build your data model or machine learning data model, then predict data, and then use UI and the XGBT and back to your to generate some new data. So for the whole process of DataOps, in my point of view, the DataOps is in this layer. As a bottom of the whole layer, we call the infrastructure, or as SRE, and some people call the AI ops here, and DevOps will including from infrastructure SRE, software engineering, and some part of data engineering, and you have to use monitoring or observability or CI/CD or SATA infra in DevOps, and for data engineering and for data scientists and the data analyst is the DataOps processing. We focus on how the big data program deployed, how to sign off, how to use the application development, and we focus on data model, data or design the data model, and how to deploy the data model, and also the data engineering pipeline and the model training, data analyst, and to do some static report, and also for the dashboard and deployment. And MOps is focused on data science and data engineering, especially for very big AI models. There are some special requirements on data preparation or model training. So I think DataOps is focused on this kind of area. And I know many new concepts all over the world. One of them, we call it data fabric. And in my point of view, DataOps is the fundamental layer for data fabric, because data fabric is is something you are using dynamic metadata intelligence to drive the whole things. You just use the augmenting the data catalog and the intelligent metadata, then you can acquire the data by the intelligent metadata and by your data marketplace. So if you want to use this kind of data, you have to use some orchestration and the DataOps tools. So many people, both in China and in American, just tell me he is doing data fabric. And the first question I will ask him will be, are you finished your DataOps tools or DataOps platform? If he didn't do DataOps first, I think the data fabric projects perhaps their project will be failed, because DataOps is very important for data fabric, and is a fundamental part of data fabric. And also for data mesh, I just heard that you mentioned you will introduce data mesh in the next meetup. It's a very popular concept, and also it's very popular in China and in Europe. For data mesh, there will be, we call it perhaps a data marketplace. That means you needn't to migrate data from one data source to the other data source. It's just has a federated governance layer that you can query the data on your federated governance layer. Then this layer will just throw your query to the right place, to the right data engine, and then get your data back and give you the result. And people, we just I just think it's decentralized data ownership, because more and more people are using data, not only the engineer. So I think data mesh is focused on people and process, and focused on analytical data, not the operational data. And data mesh let centralized architecture from a centralized architecture to distributed architecture. And also DataOps is very, very important in data mesh scenario, because the data is in different distributed architecture, and how to query and how to orchestrate the different jobs, and how to manage the metadata. So I think how to deploy the whole things. So the DataOps is also very important in this process. And I think in US, especially in Silicon Valley, there's a new word called a modern data stack. I think it's also DataOps is also very important for modern data stack. It's a key part of a modern data stack. Modern data stack is something called a set of technology based on cloud native service component. It has Snowflake as the cloud native data warehouse, and it has data ingestion tools called Airbed or SeaTunnel or Fivetran, and also it has its programming tools called DBT or something like that, and also it has many tools. And the whole trends for modern data stack is to how to let people only know SQL to run the whole data process, from the data extraction to the data loading to the data analytical process. So that's why I think the DataOps is very important for modern data stack, because the whole process will orchestrate by DataOps. And if you have a good DataOps tools, that will accelerate your programmers' performance. So I think this the whole thing that I want to communicate with you. And here is my LinkedIn. And if you want to talk me more, you can just add me in my LinkedIn, or we can just discuss, have some discussion online. Yeah. So it's very. Thank you for your listening. So any questions?
Yep, thank you, William. So